All right, what's up, everyone? Yo, it's been a long time. It's been a while. Yeah, who am I? Who's this? I tried to grow a beard to show that time had passed. Not very happy with the end result. So, first of all, did you miss me? Yeah. All right. That's good to hear. How was remote week? Did you have a good time? Yeah. Like I never want to go back. Just keep me here at Lighthouse. I mean, there's a couple reasons that we do remote week, or at least in the 10-week curriculum. One of the reasons is to show you how much you need us. No, it's to give you a chance to like learn on your own, right? And start building things on your own that way. But I do want to encourage you to think back on the stuff that you learned in remote week. The two things that you learned. The computer science stuff I think is pretty valuable and interesting. If it didn't like really click with you perfectly, that's totally fine. It took me 6 years for that stuff to click. So don't stress about it too much, but it's more something to just keep in mind and just to be aware of its existence. The only real time that you'll need to worry about the computer sciencey stuff is maybe in an interview. There's some like classic interview questions. If you're interested in what those kinds of questions are, I recommend, first of all, continuing to do that stuff from before. Oh, this is my intro to hip hop playlist that I'm at 29 songs now. The one I was telling you about. Yeah. So, if you're thinking right now of like when you have some extra time, if you have any extra time, to look at what interview questions might be like, I do recommend cracking the coding interview. It's a book. It is a big green book. Where you at? It's a big green book. It's a pretty big book. It's thick. It's like that big. You don't need to read all of it. Barely need to read any of it. Most of it is solutions, because the first little chunk is questions. So there's like interview questions and solutions, and the interview questions are split into categories. You don't need to care about all the categories. Specifically, the things that I recommend maybe taking a look at are the explanation of what different kinds of interviews are like, right? So these don't necessarily go into like the questions, but more like what is the process like. Just if you're new to the tech world, the interview process for a tech job is different than the interview process for another job. So it's worth kind of reading into that. Palantir do they do military stuff, I think? Yeah. Private American software company, big data analytics. I'm pretty sure they sell stuff to the military or something. Yeah, U.S. military, intelligence and police. They like spy on you or whatever. Like that's in Sydney? Ooh. Yeah. But headquarters is Palo Alto. So, they look at like what it's like to get interviewed at a couple of different like big companies. What it's like for different kinds of situations, like maybe if you're interviewing at a startup, maybe the different kinds of people that are interviewing you. Are you being interviewed by a dev lead or whatever? For example, yesterday an alumni asked me what it means when you have an interview with the CEO, right? And it's like, okay, well, commonly if you have an interview with the CEO, it's like a culture fit interview. Right? It'll be like the only reason that the CEO would take time out of their day to meet with you is because you pretty much got it, and they just need to make one final check that you're not like weird. Yeah. We're right here, dude. Yeah. But I mean, if you want, like, by all means. So something worth kind of taking a look at, and then ultimately they also have questions like these. Big O. You're familiar with Big O now. Who here is going to pick Big O as their rapper name for their their album. Big O. You know there's a little, well, it's not big O, it's big, there's big theta. Big theta. So big O is an upper bound for a function. Cool. Big omega is a lower bound. And then big theta is if the two bounds kind of like agree. Yeah, it's fun facts. You seem so thrilled by this, Nick. Yeah? Did you all like the computer science stuff? Can you put up your hand if you actually did really enjoy it? Yes! All right. Do I have a 6-year degree for you? So no, if like it's good stuff to kind of learn, and you know the questions in here are going to help you out with like interviews, but they also do. I'm just shilling the book now. They do have questions that are more along the lines of OOP. If you haven't talked a lot about object-oriented design, but you will next week. So, do I recommend buying the book? No, don't buy it. Do I recommend somehow acquiring a copy of it? Yeah. What? No, what? What is a torrent? I don't understand what a torrent. All right. So yeah, I just wanted to toss that out there. Now, today we are dealing with prototypes in JavaScript. Java. Not a lot of people know this, but the J is silent. So we're going to deal with prototypes in JavaScript. I want to give you a heads up. I'm going to put this in bold. You don't like really need to know this stuff backwards. Know this stuff like inside and out. Inside and out. Today's lecture is more like, oh, I didn't know that that's how the sausage is made. Cool. I'll probably still keep eating sausages, but I'll feel a little guilty about it. Like that's what today's lecture is about. You will have exercises like assignments today that are about dealing with prototypes. But I want to stress that you can be a great JavaScript developer without fully understanding exactly what's going on here. Right? I will do my best to show you. Reason I bring that up is I went a really long time without even knowing what prototypes were. So don't feel bad. Now, I think that we'll start off by talking about objects. All right, let's take a trip way back to week 1. Somebody help me make an object here. How do I make an object? How do we make objects? All right. Cool. Now I could have keys and values in it. I mean, this here on its own, pretty good. This is a very good object. What kind of object is this? It's an empty object, right? What did you say? Yeah, it's an object literal. That's actually great. Yeah, I'm going to write that down. So object literal, we're going to talk about what that means in depth in a sec. And then specifically, empty object. Now I'm going to hop into my console. So, boop. We'll pop out the console for the day. Boop. And boop. OK. So I'll spend a bit of time working in the browser console just because I like the inspector here. We'll make a nice little empty object. There we go. A little harmless empty object. Let's open it up a little bit. What do we expect there to be in there? Huh? Get out of here. that's yeah. No, we're expecting there to be nothing in here. Yeah. Oh no. Oh. I didn't write proto. What is this? Get out of here. I didn't do that. We're gonna hide that. Right. So apparently there's this proto. And what? I didn't write any of this stuff. There's so much. Proto constructor is prototype of.
Didn't you tell us to ignore this a while back?
I did tell you to ignore it. Well, now don't. Right, here it is. Huh. Right, there's all kinds of stuff in here. There's a value of. Some of these things seem to be functions. Some of these are function object. All right, I'm gonna just hide this again and go back to the nice little place that I was in before. So apparently, objects in JavaScript are not what they seem, right? There's more than meets the eye, at least more than immediately meets the eye. So we can create objects using object literals, right? You use the word literal. Literal, when you're talking about programming, it means you're literally writing out the thing, right? Like if I write out function, whatever, this is like a literal thing. I could go const the func, and here is a function literal, right? I'm spelling it out. We can also create objects in surprising ways. For example, the function constructor. Now, I'm just going to make my way over to the script. I have a pre-written kind of set of things. And we're gonna be working with each of these pieces in the inspector and see what they do. So here's a literal object. Here's a literal number, right? Num equals and then the number itself. A function constructor is a function that's used to create a new object, right? Surprisingly, in JavaScript, there's many ways of creating new objects. Sometimes I want to make many objects that have a similar structure. I want to create many objects that have a similar structure. For example, I want to create many objects that go name, Kanye West, and then adlib, easy. It's not really his adlib. It's more like insert strange political stuff. I want to maybe create a bunch of objects that follow the structure. So maybe another one that says Gucci Mane. And then his adlib is brr. And if I just keep making more and more of these objects and like by literally writing them out, there's nothing particularly wrong with it. But what I would like to have is a thing to generate the object easily that maybe I can pass parameters to. So what we make is a thing called the function constructor, where a function constructor might say, like, here is how an artist gets made. So for an example, an artist, and we're going to use the word this. An artist is going to have a name. And maybe I'll just set the name right now to Kanye West. And an artist might also have an adlib. And I'm just going to go back to easy. And this is a legal function. What are let's just point out some of the things that we see about this function that are maybe different than other functions we've dealt with before. Right, I can count three. All right, so it will take arguments in the future, but good catch. Yes. Right, so the name is capitalized. Right, we'll capitalize to indicate that this is a function constructor. It's for creating an object. Right, you've been working with classes recently. We will talk about classes some more. But this here is specifying that there is a type of thing called an artist. Right, so the name up here is capitalized. What else is there that's special about this? It's not returning anything, right? This function doesn't actually end up returning anything, right? It just says this, yada, yada, and then nothing else, right? So there's no return statement. And then the last thing is the fact that we're using this dot name. What the heck is this dot? Is this the window? Maybe, right? This is, I think, one of the most confusing concepts in JavaScript. This in JavaScript does not behave the same way as this in other programming languages. This is going to be a reference to the current context of what's like running, so we can deal with whatever's currently running. Basically, the way I'm going to be using this function is I'm not just going to say artist. I'm going to say new artist. Right? You've probably seen the word new before. New is used to instantiate a new object. Right? It's used to instantiate a whole new thing using, in this case here, a function constructor. So notice again, if I go artist on its own, I don't actually get any output. And I don't get any output because I have no return statement. Right? That's totally fine. This is a function that's designed to be used with new. And new is going to create an object. And it's going to create it following the structure of what I've said this object should have. Right? So this object should have the name Kanye West. This object should have the adlib Yeezy. It's going to be useful for me if maybe I want to change up the way my artist function constructor looks. You had mentioned there wasn't a parameter going in, so maybe I'll put in a name and an adlib, and I'll say that the object that gets created, that object's name is going to be the name that comes in through the parameter, and that object that gets created, its adlib is going to be the adlib from the parameter. So here now what I can do is go, all right, well, let's make a new artist. Let me save this maybe as Kanye. And this artist is going to have the name Kanye West. And it's going to have the adlib Yeezy. Sorry, crossed my wires. And here's Kanye. I mean, what do we notice about the Kanye object versus maybe this other object here that I've made? Can we point out some of the differences between this one and this one here? It has a type of artist, right? So this here is a plain object. This here isn't just an object, it's an artist object, right? An artist object. Maybe that means something to us. Semantically, it might mean that this object here is used to represent an artist, right? Maybe I could check what type of thing it is or whatever. But particularly it's the fact that it being an artist object, I can expect there to be several things in there. You might have noticed when we're working in Express, for example, or just in Node. Say I'm going to go into Node. My Node just takes a little while to turn on. All right, here's Node. You might have noticed that say you bring in, what is it, HTTP. Here's HTTP or whatever. If I look way up at the top, oh, damn, that was a bad example. We'll do I have Express installed globally? I don't. Oh, I know. We'll do that again. We'll go const HTTP, and then we'll say console.log http.create server. Okay. So when I create a server, it is a, where you at? Snap. All right. Take my word for it. I'm not doing it properly right now, but, oh no, wait, there it is. Server. Excellent. So when I create server, it creates a server object. Not just a regular object, but a server object. And me seeing that it's a server object, I can expect there to be several things in there, such as, for example, max headers count or timeout or whatever. Now, among the things that are interesting about creating objects with function constructors is if I go ahead and I make another object like Gucci equals, and then I'll go new artist, and this one's going to be Gucci main with the adlib brr. When I check into Gucci, Gucci has a different set of information, and Gucci is independent from Kanye West. I have two different objects right now. They're completely separate, but they have similar structures. They have similar structures in the sense that they have the similar properties. But what we'll see in the next little bit is that when we create different objects, they can have their own independent behaviors that interact on themselves. So I might be able to make Kanye West shout out his adlib, right? by giving every artist the ability to shout out an ad lib. And that's something we're going to see in a bit. Does this idea so far make some sense? Yeah. Yep. Without the this? Right, so let's see it. If I do, I'm just going to copy this real quick to put into the notes for you. So if we did this without the this, so just like that?
Yeah.
Cool.
And then just
Like at the end?
oh no, or colon.
Oh, you're thinking this. All right, sure. Well, let's see what this looks like. Adlib. Right. So this here is a function. What? I hate this. How is this legal syntax? How's that legal? But this, like over here, but this isn't an, like, what? Oh, is this some new syntax that they made without telling me? No, so if I put a I hate this. Let's forget you ever mentioned that. I'm gonna copy this over. I'm gonna do some research, and I might have to go like walk around for a little while. That's a while ago. So you're gonna do the Ruby lecture tomorrow, not tomorrow, but next week. I was doing the Ruby lecture, and I was telling people there's a thing called a symbol, and a symbol is like a string that starts off with a colon. But what I was telling people is like, oh, you can take a string and you can add it to another string, right? Or you can take a string in Ruby and you can go uppercase to make it uppercase. And I was like, symbols, you use symbols because you don't need to do things like uppercase and whatever. And I'm like, see, like this would give me an error, and then it didn't give me an error, and I had to take a break early so that I could get over my feelings a little bit. Anyways, so that's a little bit of a journey into my anxiety. So what we're dealing with here is when we have an object constructor or a function constructor, we can say new and we can get the thing out. So here is cat, right? Similar to Kanye. Here's dog, right? Similar to the artist thing, I guess, that we did where we put in a parameter so you can use that stuff, right? And if I make a couple different things, they're going to be independent. Now,
what were you expecting to happen with the other one? I know you said not to mention it, but like, what would have been the error?
what was I expecting? Well, yeah, because this isn't. If I tried to write that in like this, like I would expect there to be a. How's that legal? Is that legal code? Oh no, my computer froze. Yeah. Oh man. No, because if we go to Node, am I allowed to go hello world? This is unacceptable. What does this code mean? I have no idea. Yeah. Yeah, this is. You're throwing me into, yeah. Well, no, hello isn't a function. I'm doing like a key value pair, but outside of an object. No, it's not a thing. Yeah, hello's not defined. Bizarre. I'll have to figure this out maybe while we're on a break. The thing that I did want to show us though is that there are other ways to create objects. I had this artist thing, and when I made an artist like Kanye West, Kanye, when I look into Kanye and said Kanye is an artist, I open this up and I've got a proto. And the prototype of Kanye, or rather the prototype of Kanye comes from up, which has a constructor, function, artist. Now, we're going to talk about what proto is kind of more in depth as we go into the second half of the thing. But I'll say that JavaScript is a language built around the idea of being able to use objects to create other objects as like a blueprint. Right? It's like a very, I can take this object, I can make a copy of it and add more things, where it's using that thing as a blueprint. So say I'm talking about houses, and I want to make many different houses. I might come up with what the blueprint of a house is and use that as the prototype for every house that I built. And that's what proto is going to mean, is we're going to be making our way up the chain of where we're inheriting our structure from. So for example, the Kanye object here inherits from running the artist constructor. And this one here inherits from just the regular object. So there's the Kanye object, which is a type of artist object, which is a type of object. And I can also use straight up objects as prototypes for creating other things. So we'll see what this example looks like in a second. I could have, say, an object called gecko. My gecko might have type lizard, legs 4, tail true, savings 20%. And if I have this object here, regular key value pair, my gecko does not have a type. It has a proto of object. Among the things that I can do is I can create a new JavaScript object based on the gecko prototype. And what I get now is, what is this? One would think it's an empty object, and I might even go let gecko equals object create off of gecko. And my gecko being an empty object, I might assume that I don't have any properties in there, but I'm actually able to go gecko.type. Right? I'm actually able to see that stuff because if I look into gecko, working my way up the proto is where that stuff is stored. Right? So it's just another way to embed information into an object. Now, what could this be useful for? Like either one of these things, it could be used for when we're creating, say, this function constructor thing. Right? Maybe we want to create a server object, right? Like the ones that we've used for Express and stuff like that. Right? I should be able to create many different server objects. Like off of the same script, I might be able to run 2 servers. I've never actually tried that before. Or I might be able to run multiple clients off of the same script. Right? I should be able to create those and save those into separate objects. And inside of them, I should be able to see the properties that are needed to handle a client or a server or a database connection or all that stuff. And this here, for right now, it's just another way to do the same thing. But instead of storing this stuff at the root level, or at the bottom level, I guess I'll call it, it stores it a level up inside of the prototype. In general, whenever you write dot something, so say I go array dot length. JavaScript is going to go and see if it can find that property inside of the object that you're dealing with. Right? So an array is an object. Right? Everything is an object in JavaScript. So array dot length, we're going to go in and we're going to see that an array has a length of 0. But there are other things that exist for arrays. For example, an array can have a concat property. Right? Notice that the concat property doesn't exist immediately in the array. It exists in the prototype of an array. So if I go maybe array 1, 2, 3 dot concat 4, 5, 6. I get 1, 2, 3, 4, 5, 6. But no array has the immediate concat property available here. What JavaScript does is it hops up the prototype chain. And if I can't find it here, I'm going to go up. If I can't find it there, I'm going to go up. If I can't find it there, I'm going to go up. You can create objects that are made out of prototypes, that are made out of other prototypes, that are made out of prototypes. You can have this infinite chain if you want. I would kind of stop somewhere where things kind of make sense. So as in the second half, we're going to work on a slightly bigger demo. We'll see why we would want to make maybe different prototypes that inherit from each other. Now, the thing that I want to point out is that we can change what the inherited prototype has. So if I go array.prototype, I'm actually able to see what the prototype of every array looks like. And I could add something to it. Now, it's not necessarily going to work like this, I don't think. I've done it in a different way, but we'll just see what it does. It's legal for me to go array prototype, say easy is going to go easy. And that's legal. And I think I'm going to get this wrong, but I think every array now might have a say easy function. Yeah, sweet. Oh, I didn't get it wrong. There you go. So now I've added a say easy function to every single array in JavaScript from now on, forever, on this tab. Okay. On this tab, every array is going to have this one here, 1, 2, 3. Say easy. Easy, right? Like. So undefined in this case is whenever you run a function, it'll do all the stuff inside of the function, and then in the inspector, it'll print out the return value. My say easy doesn't have a return value, so it doesn't have anything to return. And instead, maybe if instead of console logging, I returned easy, now when I run it, I'll just get easy. Does that make more sense? Cool. Right? This could be cool, because you might decide that maybe different types should have some stuff that they don't have yet. Right? For example, maybe every number should be able to add 1. Right? So I should be able to, what is number.epsilon? Cool. Number.prototype.add 1. Right? I would like to be able to use a function that takes any number and it returns. Can I do this? Return maybe this plus 1. I don't actually know what the value of this is yet, so we'll see. And now I might be able to go 1, add 1. Guess not. Not allowed to do that. What about? There we go. Yeah. So now I have my syntax was just wrong. With numbers, you have to wrap them in brackets. But I can do. I like your reaction. There you go. It's just pretty cool, right? From now on, I can have an add 1 or divide by 2 or whatever. Okay. Neat. This is the point behind having prototypes in JavaScript, is it makes it really easy for us to augment the things that a particular type is able to do. Right? JavaScript gives you some basic types, the primitives. Right? They give you like, okay, you got your booleans, you got your numbers. Here's some extra stuff that you can do with it if you so choose. Right? In fact, when part of the reason that we bring in libraries, right, is to augment the stuff that we want to do with code. Some kinds of libraries are called polyfills. Right? And a polyfill is a library that comes in and fills in extra functionality for particular types. Right? Maybe functionality that should already be there, but for some reason your machine doesn't have it yet. Yeah.
Is that what jQuery does?
Sort of. So say, for example, like you know about promises now, right? Promises took a while to roll out, like across browsers. So it might have been the case that like Firefox and Chrome had promises, and you could use promises in there. But like Internet Explorer didn't support promises yet, right? So what you could do is, I don't think jQuery had promises in there, but say like there's a thing called Bluebird, which was it's a library that you can go, and it gives you what's called a promise polyfill. So I could npm install Bluebird, and then from then on, I'd be able to bring in promise. Actually, they did it as a library, but there's a promise polyfill. Yeah, promise polyfill that gives Internet Explorer the ability to run the code exactly the same way as Chrome would and stuff like that, right? jQuery doesn't necessarily do that. In fact, they put all their stuff on the scope of jQuery. But imagine that if jQuery took their things and instead they injected it into the values that already exist. Right? Point of it being that like I can choose to say that every number should now have an add one. Then I can create that myself. And anytime I want, I could just add more stuff to it. Right? In fact, part of what was going on with that gecko object, which I'll bring up again in a sec. I'm gonna put this back in the notes so we see that, and then add one. Part of what was happening with the gecko object is just going way back. Where you at? So here's the gecko, and I go gecko equals object.create gecko. Is that now I could add more things to my gecko, or to like the gecko's prototype by going gecko.prototype. No, did I get this wrong? I did. That's not a real thing. So one of the troubles with prototypes and one of the troubles with objects in JavaScript is that there's so many different ways of creating them that often I'll find myself thinking in loops. Like I'll start following a thing. There's the word prototype, and there's also proto, and they kind of mean two different things. So where'd you go? Where'd you go? Whoop. Okay. Dot prototype is saying when I use this to create new things, what will those things have? So for example, for my array, I can create arrays with object literals, with array literals, but I can also create arrays by going new array. Right? This is really just shorthand for this. You didn't know this, but now you do. So this is shorthand for this. And dot prototype means anytime I use array prototype, what should my things that are created with this actually have? Okay? That's what prototype's going to mean. You go object.prototype. And I could say object.prototype who the best. And then we might return DJ Khaled. I don't know. And now literally every object in JavaScript should have a who the best thing, right?
So an array would have the same thing?
Probably, yeah. Yeah. All right, so an array is going to have the same thing. So prototype, like dot prototype means when I use this as a constructor, right, or as a thing for like constructing things, what will they have? Again, this syntax, similar to the array syntax, I can go new object. Right? This here is just shorthand for this. Right? On the other hand, though, dot proto means who am I inheriting from? So I can look into an object and the underscore underscore proto underscore underscore lets you go up the chain to see where you received your information from, where you received your structure from. Does that idea makes sense, right? The motivation again of it is to make creating new things easier, right? You've actually been dealing with this stuff through React, right? In React, you dealt with classes, right? And classes are just another way of creating objects that we're going to spend like a bit of time talking about after the break. I want to see if there's anything else I want to show you here. Not really. So we've got object literals, function constructors, object create, which just never use this. I don't understand it. I don't ever see anybody doing this. Yeah. Mm-hmm. Yep. You can use any, like literally any object. And object.create is going to let you create an object off of that prototype. Then I'm never like able to go access that prototype and change it again to affect it downwards. Like with the function constructor, right, I was able to go add stuff to the array prototype. Right? With object create, I'm not able to go add stuff to this object and have that rain down anymore. Right? Yep.
So if you're able to add new properties, are you also able to delete one?
That's a good question. Let's see. So arrays, let's see, an array is going to have a length, I guess. Oh, but the length is immediately in the array. Let's see. An array has, we'll say map, like every array, or pop. That one's pretty easy. Say every array has a pop. So we have 1, 2, 3 dot pop is going to get me the number 3. And if I had it as r is 1, 2, 3, and I go r dot pop, now r is 1, 2. We could see if we go array dot prototype dot pop equals like null to get rid of that. Maybe we can't pop anymore. We're not able to pop anymore, right? So you can, oh man, the absolute power, yeah, like you can do cool stuff. I mean, why would you want to do this, right? Like I might now change pop to like array.prototype.push, haha, right? And now every time somebody tries to pop, no, oh, whoops, because that's I needed to write this as an arrow function, my bad. There you go. Now every time somebody tries to pop, yeah, then it's running the function, and I can look at my the array that's being made. Why is the number going up every time, eh? Who knows? I mean, we're in uncharted territory here. So I go 1, 2, 3 as my R1, and every time I go R1 dot pop, and I check R1, yeah, it just keeps getting new numbers in there. Did it? I don't know where this number is increasing from, to be honest. I have no idea. Yeah. Oh, you know why? Because I'm not supposed to say array.prototype.push. It's supposed to be this.push. There we go. So now if I do let r equals 1, 2, 3, and I go r.pop. Oh, who knows? Yeah, you've stumped me. Dude, it's fun to mess around with this stuff, though, right? And I think, like I've said to your cohort before, the best way to learn is just by breaking things. It's just a good time. So we'll take how does a 10 to 15 minute break sound? Pretty good? Pretty primo? Right, go out and enjoy the sun for a little while. And then we'll get back and start working on classes. And audio's working. All right. So what we're dealing with now is. Wait. Hey, excuse me. Sorry. The lecture's about to happen. Sorry. All right. So what we're dealing with now is we're going to hop into some more ways to create objects, as if there weren't enough already. So this final way is going to be using classes. Classes are really just syntactic sugar for function constructors. Pretty much the same thing, right? Classes are going to give us the ability to, in a nice and simple way, sort of, like it's a syntax that's familiar to people who are used to other kinds of languages, to create the blueprint for an object. Now, I've used the word object a lot. I'm going to use the word object a lot next week. I want to stress that in JavaScript, objects are key value pairs. Right? They're key value pairs, and we can have unique instances of those key value pairs. And we might often want to have key value pairs that follow some kind of structure. With key value pairs, the values can be any JavaScript values. Right? In JavaScript, functions are values. So it gives us this nice situation where in JavaScript I can create, and we'll do that. We'll look at this in a second, but in JavaScript I can create things like this. Say I have my function constructor, so function artist, and then it has an adlib, but I might also say this dot say adlib might be a function that returns maybe my adlib is, and then this dot adlib. Now what I'll be able to do is say I make a Kanye. Say I make a Kanye, which is a new artist. I'm able to go Kanye dot say adlib. Yeah, my adlib is easy. Right? I'm able to embed actual functionality, right, into this object. Right? So the object has properties, but it also has behavior. Some people just find this clunky. I'm not one of those people. I think this is nice. But some people find this clunky, so they came up with a class syntax. And what the class syntax looks like is, instead of me going this dot name and this dot adlib, these two things here just kind of loosely on their own, with class syntax, people end up putting that inside of, you just paste this at the bottom, people end up putting that inside of a constructor method. And the constructor method is going to say, this object that gets created with this class is going to have pause be 4 and color be orange. Also, I'm going to have a meow method in this case here. For us, with the artist thing, it would have looked like artist and this dot name and adlib, and then this would have been say adlib. Right? Where we're defining both the data that object's supposed to have, but also the behavior that object is supposed to have. And the slight difference between what I've done here is that when I've embedded this say adlib thing into this, when I look at artist.prototype, I don't actually have the method available inside of the artist prototype. So if I wanted to change what an artist says, I'm not actually able to do that after the fact. Right? If I look at Kanye, say adlib lives at the floor level. If I did this other thing though with classes, structured this way, okay, so cat class has the constructor, and then instead of me writing that stuff, the meow, instead of me writing it directly inside of this dot meow like that, but I write it in this structure, what I'm going to find is when I go like cat, new cat class, my cat is now going to have pause and color, and the meow actually lives up in the proto. Right? For us, no real functional difference other than the fact that when I have it structured this way, I'm actually able to go cat class dot prototype and change what a meow is supposed to be. So I might go, oh, well, the meow is now a moo, right? Moo. And I just pressed enter 3 times by accident. But if I go cat.moo now, no, cat.meow, now my cat moves. I'm not able to do that in the other way that I did the thing. Okay. So classes are going to give us a little bit more fluidity, I guess. I haven't really found a ton of use in that personally, because it's not very often that you're going to go and override what a method's supposed to do. So we've got these classes. We're going to play around with them quite a bit because we can do interesting things with these classes that are a bit easier to do than when we're dealing with function constructors and when we're thinking about proto and prototype. You might find, like, you might have noticed that I get really uncomfortable talking about this stuff. We were talking earlier about how, like, JavaScript just has a really weird way of handling this stuff. And I find that wrapping your head around prototypes can be a little bit weird if you have previous experience coding in a different language. There are languages that have actual classes and are actual like object-oriented languages. You will find out what that means next week, but for right now, let me just say that a class in other languages is a really strict thing. Right? A class in JavaScript is just super loose. You're like, ooh, I'm just an object, but with a special hat, right? Like that's all it is. So I mentioned a couple times that like we could have prototypes that are then used as prototypes for something else, that are used for prototypes for something else, and we could have this whole big chain. We're going to look at an actual example where that's going to be useful to us. So I'm going to start really defining the term inherit, which I've used before. You've probably loosely talked about inheritance while like in the intro to React. Yep.
That's like the extend.
Yeah, exactly. So in React, or when we're talking about JavaScript classes, you'll use the word extends. And extends is going to mean use this other thing as a prototype for me. Right? It's just nice language to say, I want to create a new prototype based off of an old prototype. Okay? So for example, I might have a mammal. This isn't real code. This is pseudocode. I might have the idea of a mammal. I'll say a mammal is going to have DNA and eyes, maybe fur. And then I'll be able to create new mammals, right? All sorts of them. If I find that a lot of the mammals that I'm creating follow a certain structure, then I might want to make a more specific structure that builds off of mammal. For example, cat type. Right? I might say that cat type is a mammal type, but also has pointy ears in my example. Cat type has whiskers and is a jerk. Right? Just, that's cat type. And then maybe I'll make a dog type, which is also a mammal type. For my example, dogs are only going to have round ears. And dogs will also have whiskers, but they're going to be nice. And now, what I should be able to do, this is again not real code, But in my mental model of how this works is I should be able to create Spot, who is a new dog, and the dog is a type of mammal. And I should be able to create Felix, who is a new cat, and also a cat is a type of mammal. So maybe they have some shared things, right? But I'm able to use that structure to create new complicated things. This is very similar in idea to what you did with React. With React, you are making new components, right? I'll make a new chat bar component. I'll make a new nav bar or message list component. Right? And if I was to kind of list out what your chat bar component was like here's my chat bar. Yeah, we'll go let chat bar type. Okay, is a React component, right? Meaning that it can be seen on the screen, right? Updates with new data, right? Can be mounted / unmounted. You didn't have to write any of this code, right? Like the fact that your React component reloads itself anytime a prop changes, it's not something you had to code up. It's something that the people at React, you know, wherever, ended up making, and you get to extend off of that. So a chat bar type is a React component, and then maybe it displays the inputs for name and message. Right? And if I go ahead and I make another type, let navbar type, right, you may have in your navbar the fact that it can show the number of people that are currently in the app. So it shows how many people are in the app, but then it's also a React component. Right? It's also a React component. Now, it would be weird for us to have to write this piece of functionality like 2 times to write all of the code that makes a component work and just have to write that out every single time. That's a lot of work. So instead, the idea that we're leveraging is inheritance, meaning let me take this thing over here, let me move that over somewhere else, and this will say what a React component technically is. Right? A component can be seen on the screen, updates with new data. And now for each one of these, I might say, well, the chat bar type is a component type. Right? The syntax that we use in JavaScript is going to be extends, right? And that's something you've gotten familiar with this at this point. Again, I know this is a review, but it's because we're going to build off of this in a second. So are there any questions about this at the moment? I want you to equate, or not equate, but like relate the ideas of don't repeat yourself with inheritance. Right? The main place where inheritance pops up is where you find yourself writing the same code multiple times, right, to create similar structured objects. You take that and you put it into one place. Right? That's what inheritance is really all about. So here's a big-ish example of dealing with musicians and artists using classes. So I have this class artist. Every artist is going to have a genre that maybe starts off as blank. And also every artist has a tagline or an ad lib, like a sound that they make. And the tagline is going to be to console log this dot tagline. Notice that at the moment, an artist doesn't have a tagline. So if I go ahead and I take that stuff here, just boop, and boop, boop. It's ad block popping up stuff. If I take this stuff here, I can have my artist class. I can even make a new artist. So here's Kid Cudi. And I could attach a genre maybe to Kid Cudi, good music. If I go Kid Cudi dot, I can see inside of here that like eventually I'm going to have, say, tagline. It is a function, But when I run it, there's nothing for this .tagline, so it's just undefined, okay, which is fine. Now, I could also make another class that extends what an artist is. All right, let's extend the idea of what an artist could be. Here's a rock artist. And a rock artist, a rock artist maybe has the genre set to rock, right? So it still has the ability to have a tagline, and its genre, instead of being blank, is going to be rock. I'm going to say that every rock artist is also going to have a best ballad, because for some reason, every rock album, like, I don't know, every Kiss album has a, I don't like Kiss anymore. I don't like Gene Simmons. He's not a nice guy. He's mean. But they all have a ballad. What do we notice in here? What does super mean? Sort of. So super can mean, we could say inheriting from the parent. I want to say that super is a reference to the parent's constructor. Right? In this case here, say I have rock artist. Right? That's just my ad blocker again. Say I have rock artist. If I was to go ahead and create a new rock artist, when I've created a new rock artist, that goes and calls the rock artist constructor. And the rock artist constructor has this .genre as rock and this .best ballad. But since I extend artist, I should also make sure that I have a tagline method for my rock artist. In order to make sure that that happens, I have to call super. And I have to call super because since I'm overwriting the constructor that I had inherited, I need to make sure to manually call the overridden constructor. And so to put inheritance into like slightly simpler terms, I guess. Oh, actually, let me show this real quick. During the break, a couple of us were talking, and I pointed out this. Dot prototype means you're going from the global thing down, and dot underscore underscore proto underscore underscore just goes up, right? So they both take you to the same place. Right? So this is what the global or the big thing is going to be using to create smaller things, and this is what the smaller thing inherited from. If it helps, that's why I had Spider-Man up. Just, like that's what's going on. So just to go back to this though real quick. We were talking about how inheritance works. You're going to get more time to kind of explore this next week. Actually, next week is a big chunk of this. Basically, if I have an artist, and an artist has a constructor, and maybe a method for, say, tagline. If I go down and I say a rock artist inherits from, I'm just going to use this symbol to say inherits from artist, or extends artist. This on its own like this, totally fine. It means if I go rock artist dot constructor, it takes me up because it can't find it here. And if I'm here and I say rock artist dot say tagline, can't find it here, so it makes its way up and it finds it here. However, if I'm here and I say constructor, so I go rock artist dot constructor, it finds it immediately, so it never goes up to look for the other one. Right? It just won't do it. Same with if I go say tagline. Right? If I make a new say tagline method down here, JavaScript's going to look here first, find it, and they won't keep looking. That's why if I want this constructor to actually have the stuff that this constructor had as well, I need to explicitly say in here, call my parent constructor. Right? Same with my tagline. If I was overriding the tagline, but I still wanted to use some stuff up here, I would have to say, call my parents say tagline. And I'm not going to do this right now. So JavaScript is actually so, funny enough, they're actually kind of strict about this. If I try to create a class like classical, and in my constructor, I don't put super. When I try to create a new classical artist, I actually get an error because it's not legal for me to have a constructor in an extended class that doesn't have a call to super, right? Because JavaScript knows that if I'm doing that, then I've made a mistake, right? The only reason that I should be extending and overriding constructor is because I want to have both of these things. If you're not calling super, then why did you extend in the first place? Right? Does that make sense? So it's funny, this is like one case where JavaScript actually does act a little bit strictly about that. Now, making our way back to just what we had before. So I'm actually going to leave this page, and I'm going to do a different one. So I stopped getting those ad block errors. So what I've made was all the way from this, Kid Cudi, we've got Rock Artist, all the way down to Zeppelin. So I have Zeppelin. Zeppelin is a rock artist. I follow rock artist to get artist, and I follow artist to get object. And that's where I have this chain. And this chain is a bit nicer to set up through classes, I find, than with the function constructors. Notice I didn't even technically use the word prototype anywhere in this structure, right? And this code just makes a bit more sense. Since I have Zeppelin now, among the things that I could do is I could ask for Zeppelin's tagline, which is undefined at the moment. I never set it. So I could go Zeppelin.tagline and set this to, they're always like, Robert Plant's always like, wah, and then mama at the end. So now my tagline is that. Right? And I'm able to actually have some behavior that enacts on my data. What we're getting close to now is just kind of like a different way of thinking about programming in general, where with object-oriented programming, we think about our code as being these siloed off living chunks, like living, breathing things. Like a server can be created, and it can do things, and then it dies, right? Or our components, they get created, they get put on the screen, they interact with things. Maybe there's many of them, and they're friends, and then, they die. That's sad. But you know what I mean, right? We could technically do all this kind of stuff dealing with functions or without objects in the first place or whatever. It just becomes a little bit harder to think about in terms of like bigger projects, right? So this gives us a nice framework for thinking about siloed off actual constructs that interact with each other. Now, I might have a class hip hop artist. Hip hop artist. In this case here, I've overwritten what the constructor for artist was. When I made a rock artist, my constructor didn't have a parameter. But when I'm making a hip hop artist, I've decided that I do want a parameter. And I'm going to set the genre to hip hop. And I also have a thing in here, a Boolean called is Kanye. That will be true if the artist that I've made is Kanye. And it'll be false if the artist I've made is not Kanye. So now, when I go ahead and I make a new artist like Nikki, when I check Nikki.isKanye, Nikki's not Kanye. But if I go ahead and I make a new artist called Kanye, and my artist's name is Kanye West, when I check to see whether Kanye is Kanye, that's true. Right? So I can do all kinds of stuff in my constructor Maybe I want to set up socket connections like you did for your thing, right? Or all kinds of stuff. I could do some computation in there. Right? The constructor is just code that's going to run when I go new. It'll run once. Should I do, let's see, one last thing. Remember the thing I did with the array.prototype? I went and changed the prototype of stuff. Say that I tell the artist prototype to have a tagline of I am an artist. So the artist, like every artist is going to have the tagline I am an artist. That means Kanye, when I call say tagline, is going to say I am an artist. And Nikki, when I go say tagline, is going to say I am an artist. But if I go Zeppelin dot say tagline, I get wah mama, right? Because JavaScript's going to start from the bottom, right? And it's going to look at Zeppelin and it's going to say, hey, does Zeppelin have a tagline? Yeah, Zeppelin has a tagline, so I won't keep making my way up to find what the tagline is. Right? Whereas for Kanye and Nikki never got an explicit tagline set. So when JavaScript looks for the tagline, it'll work its way up until it finds it in the prototype. In my opinion, yeah?
So for that one, if you did a prototype object instead of artist, that would go past artist would be going up.
Can you,
Object of prototype.
like this here? Right, so, I mean, we could see what would happen if I did object prototype tagline. So that would be changing this a bit. Let me just copy all of this stuff. Then object prototype tagline. Oh, it breaks because of my Mozart thing that's supposed to break. But let me just do. So object prototype tagline. Kanye said tagline is going to say I'm an artist. And then Zeppelin say tagline is going to say wah. Because that's just what I'd set up there. But if I go this dot say tagline, is that a thing? Okay, good. Wait, why? Object. Oh, because it's tagline. Whoops. Tagline. I set it as a property, not as a method. So yeah, now everything has the tagline I am an artist. They just don't have the say tagline method, which only artists have. Cool? Cool. Did you find this helpful? Do you see what I mean about, you can use JavaScript without fully understanding this stuff, right? In fact, I hate JavaScript. This is the worst language on earth, right? It's just silly. When you see how things work in Ruby next week, I find that they just make a lot more intuitive sense, right? JavaScript very much feels like a language that people hacked together. They're like, oh, we forgot about this thing it's supposed to do. Sneak it in, right? Just get it in there. So if you love JavaScript and you want to become a JavaScript expert, by all means, really learn how prototypes work. There's even a great book series called You Don't Know JS. It's kind of funny, but You Don't Know JS is a book series. You can buy the physical books, or they have the actual books for free on GitHub, which I do recommend taking a look at after boot camp. And they have all kinds of stuff in here on how different parts of JavaScript work when you're going deep into it. So for example, scope and closures might be something to really take a look at. This and object prototypes also something to take a look at. And then I have the book, I actually bought the book Async and Performance, and it's really good. Right? But all of these things are free on the GitHub page. Just if you want to become a JavaScript power user. Otherwise, there's tons of other amazing languages that work slightly different. Cool. Are there Any questions? Nice. Well, have a great rest of the day. And I think I'm lecturing for you next week, but I'm mentoring for the rest of the day if you do have questions.